Okay, let's take a look at Chapter 17, Objective 9. Now, this is really probably the toughest section for students because there's so many hormones to talk about here. And this is the basic information you need to know for all hormones in this chapter, Chapter 17. You need to know the stimulus. In other words, what's the problem that causes the hormone to be secreted? You need to know where they are secreted from. So, what endocrine gland are these hormones secreted from? The target cell. Once the hormone enters the bloodstream, where's it going? And then, what is that cell going to do once it gets there? So, just the basic information for all the hormones. So, before we kind of get started on that, let's just kind of talk a little bit about endocrine glands. Endocrine glands are the areas that secrete hormones which regulate body processes. Again, we said the endocrine system, just like the nervous system, is a regulatory system of the body. Now, endocrine glands can be classified as primary or secondary. I am not going to ask you primary versus a secondary endocrine gland. I'm not going to do it. But you may say that as we move through this, well, I didn't know that was an endocrine gland. Like, I didn't know the heart was an endocrine gland. That's not its primary function. So, when you have a structure, a group of cells that their main function is to produce hormones, well, then they're a primary endocrine gland. If you have a structure in the body where its main job is to pump blood through the body, well, that's the heart. But believe it or not, it also secretes hormones, but that's not its main goal. So those would be secondary endocrine glands. So if you're looking at some of these going kidneys, intestines, adipose tissue, I didn't know those secreted hormones. Well, that's because that's not their primary function. So that's why they're called secondary. Again, I'm not going to ask you if it's a primary or secondary endocrine gland. I just have those broken up this way in the PowerPoint. We're first going to talk about the primary ones. So the hypothalamus, of course, is our first one. Now, y'all, I'm going to go ahead and tell you up front, this is going to be a little bit longer of a video than what we're usually used to having. This is going to be longer than 15 minutes. Okay, the hypothalamus and the pituitary gland together regulate every body system. So this is where it all kind of starts. The hypothalamus communicates with both parts of the pituitary gland, both the anterior and the posterior section. So you can see here's the hypothalamus. Take a look at which way this brain is facing. Remember, the cerebellum is your landmark to let you know front from back, which means right here where the cerebellum is, that is the back of the brain, which means this area up here where the hypothalamus is, that's going to be more towards the front. Now, if you take a look at the pituitary gland, so you have your hypothalamus right here, this area would be the front, this would be the back. So because this is the front of the brain, this would be your anterior pituitary, and the back part of the pituitary gland would then be called the posterior pituitary. The hypothalamus actually makes two hormones that are going to go to the posterior pituitary until they're secreted. So that's going to be antidiuretic hormone and oxytocin. So be careful on the test questions. Am I asking you where the hormone gets made or where the hormone is secreted from? Now, for antidiuretic hormone and oxytocin, they're the only two that we're going to talk about that are created in one location and yet secreted in another. All the other ones are going to be made and secreted from the same place. So these are the two exceptions here. So antidiuretic hormone made in the hypothalamus travels through, these are neurosecretory cells, so they're traveling through the axon here, and going to the posterior pituitary and dumping right into the bloodstream here. So notice they're not going through the bloodstream to get from point A to point B. They're going through a neuron. And they're going to be secreted from those axon terminals and empty right into that capillary. So antidiuretic hormone is going to target the kidneys, and that's going to result in water being returned to the bloodstream. So, if you think about what a diuretic is, if I were to ask you, what are some diuretics that you might consume, they would be caffeinated beverages. They're diuretics, meaning they make you pee. Alcohol, it's going to make you pee. So, an antidiuretic is one that's going to not have you pee. So, in other words, I kind of call it the no pee hormone, because where does that water go? It doesn't leave the body in the form of urine, it goes back into the bloodstream. You're going to keep that water instead of it excreting it out in the urine. Antidiuretic hormone. So it is going to ultimately, take a look at this, increase blood pressure. If we're going to take that antidiuretic hormone and return the water to the blood, that's going to make the blood volume higher, because you just put a lot of water in there. And if your blood volume goes up, that ultimately will cause blood pressure to go up. So there are 4 hormones that involve blood pressure, and you're going to need to know what those are. And the thing about these hormones is you're going to need to know these hormones for chapter 17 and throughout the rest of the course. So these hormones are not going away because it's a regulatory type mechanism. We're going to talk about how the endocrine system regulates all the rest of the organ systems throughout the rest of the course. So these are not going away. You need to put these in your long-term memory. Now, oxytocin, abbreviated capital O, capital T, you do need to know their abbreviations as well as their long names. You have some activities on your Moodle page to practice with this. They are for a grade, though. They're for you to practice, but they're also for a grade. So the function of oxytocin, it is made in the hypothalamus, secreted from the posterior pituitary. It is involved in contracting the uterus during childbirth and milk letdown. Be careful with the milk. You have 2 hormones involved in that. You've got one for milk production, not this one, and then one for milk letdown, the release of the milk out of the glands. That's oxytocin. So be careful. These right here are the other hormones secreted from the hypothalamus. Yes, I know there's a lot. These hormones secreted from the hypothalamus are either going to be releasing hormones. That means they're going to tell the anterior pituitary to secrete something, or they're inhibiting hormones. They are going to tell the anterior pituitary to not secrete something. And then from there, the hormones that the anterior pituitary gland does secrete will be released and go to their target cells. So the hypothalamus, these are a list of all of them. You've got prolactin releasing hormone, prolactin inhibiting hormone. You can see the positive and negative signs over here. That this lets you know if it's going to create something or cause an effect versus prevent an effect. So if it's positive, that means it's going to cause the secretion of prolactin from the anterior pituitary, versus prolactin inhibiting hormone, also known as dopamine, by the way, which will prevent prolactin from being secreted from the anterior pituitary. You have thyrotropin releasing hormone, TRH. It will cause thyroid stimulating hormone to be secreted from the anterior pituitary. Corticotropin releasing hormone, it will cause adrenocorticotropic hormone to be released from the anterior pituitary. Growth hormone releasing hormone will cause the release of growth hormone from the anterior pituitary. Growth hormone inhibiting hormone, also known as somatostatin, will prevent the release of growth hormone from the anterior pituitary. Gonadotropin releasing hormone, look at that lowercase n right there. That's the only one that has it. And it will cause follicle stimulating hormone and luteinizing hormone, your gonadotropic hormones, to be released from the anterior pituitary. I know these sound like a lot. I would make flashcards, honestly, and put like prolactin releasing hormone on one side, and it causes the release of prolactin from the anterior pituitary on the other side. And I would practice those backwards and forwards. If you notice, I want you to take a look at these names: releasing, inhibiting. Every one of these hypothalamic hormones has the word releasing or inhibiting in it if it's stimulating or inhibiting the anterior pituitary. These are the only ones that have those words. So if you automatically see a word on the test that is something something releasing hormone or something something inhibiting hormone, you automatically know it's being secreted from the hypothalamus, and you automatically know it's going to the anterior pituitary. And if you look at the names of the hormone secreted from the hypothalamus, prolactin releasing hormone, the name of the hormone that's going to cause the release is prolactin. So they do make a little bit of sense if you work on those. So again, practice, practice, practice. The pituitary gland, again, together with the hypothalamus, help regulate everything. The posterior pituitary, we've talked about this just a second ago, oxytocin and antidiuretic hormone. The cell bodies of the neurons are found in the hypothalamus. These right here are your cell bodies. Those neurotransmitters, technically, right, because that's what there are at this point, traveling down the axon, being released from the axon terminal. This structure right here is called the infundibulum. This is a stalk which attaches the pituitary gland to the hypothalamus. So the hormones travel down, actually, they're neurotransmitters at this point, travel down and then they get released into the bloodstream. Once they hit the bloodstream, they're now called hormones. And they will go into the bloodstream and go out through the body until they reach their target cells. Now, we talked about the hormones coming from the anterior pituitary, prolactin, thyroid stimulating hormone, adrenocorticotropic hormone, growth hormone, and follicle stimulating hormone and luteinizing hormone. You need to know where they're going. So, where does prolactin go? Again, these are secreting tropic hormones, meaning they're going to go somewhere else rather than stimulate or inhibit another secretion. So where is the target? Where's the end result here? Prolactin is going to the mammary glands for milk production. I know it says milk secretion on there. That should actually be milk production. And here's how you can remember that. Prolactin production, milk production. So I'm going to change that on here because that's what that really should be. So it shouldn't be milk secretion. That's oxytocin, right? So this would be milk production. I didn't know that said that until just this second, honestly. Thyroid stimulating hormone is going to cause secretion of the thyroid hormones by the thyroid gland. Now, I need you to make a note that when we're talking about thyroid hormones from the thyroid gland, these are T3 and T4. Not calcitonin. I know calcitonin comes from the thyroid gland, but it has to do with calcium regulation. These thyroid hormones are also known as metabolic hormones. Again, T3 and T4, we'll talk about those in a minute. Adrenocorticotropic hormone targets the adrenal cortex. Remember, the adrenal gland has an adrenal cortex and an adrenal medulla. Cortex is on the outside. And this is going to stimulate the secretion of cortisol. And just kind of FYI, which you're going to need to know, not on this slide, but cortisol is involved in long-term stress. It is released during long-term stress as opposed to epinephrine, which is short-term stress. Okay, growth hormone. This is going to basically target every cell in the body, causing it to grow. I'm not really going to worry about the insulin-like growth factors coming from the liver, but it does cause body-wide growth, okay? Follicle stimulating hormone and luteinizing hormone. Really, all I'm going to ask you on that, follicle stimulating and hormone and luteinizing hormone are your gonadotropic hormones. They're going to target the gonads. Gonadotropic hormones target the gonads, ovaries and testes. And we'll talk more about those when we get to reproduction. Pineal gland. So that's all for the hypothalamus and the pituitary gland. That's a lot. So the pineal gland, if you notice, you're looking at the brain here. This right here is the cerebellum. Now, if you remember from AP1, this structure right here is the thalamus. And you have between the thalamus and the cerebellum, you have that epithalamus. And the epithalamus is divided into two parts, the pineal gland and the habenula. So I'm just kind of having y'all remember what we did. The pineal gland is part of the epithalamus where melatonin gets secreted, and it's involved in your sleep-wake cycle. The melatonin will be secreted when it's dark. So the absence of light is when melatonin will be secreted, which will make you sleepy. The adrenal gland. So again, you've got two parts that we're going to talk about that are secretory. There are other parts, but the cortex, which is the outer part, and then the medulla, which is the inner part, they're the ones that secrete hormones. So here you have the adrenal gland made up of the outer part, the cortex, and the inner part, the medulla. Now, the cortex is going to secrete your glucocorticoids and your mineral corticoids. There's the E. I'm like, where'd the E go on aldosterone? So your glucocorticoids are cortisol. Your mineral corticoids are aldosterone. And take a look at both of these. You've got blood pressure involved in this. Specifically aldosterone. Look at what it does. It raises blood pressure. Cortisol is involved in long-term stress. That's when it's secreted during times of long-term stress. The adrenal cortex also secretes testosterone. It's a type of DHEA. Very small quantities. We're not going to worry about this, so it doesn't matter, male, female. Everybody's adrenal cortex secretes very, very, very small amounts of testosterone, which are involved in male characteristics. So it's not enough to, if female start making male characteristics, it's not enough for that. We're talking small, small, small amounts, but it does happen. The adrenal medulla is going to secrete adrenaline and noradrenaline, also known as epinephrine and norepinephrine. So again, it depends on the part of the world you live in as to whether you call it adrenaline or epinephrine. Same structure. Norepinephrine, noradrenaline, same thing. This is involved in your fight or flight response. This is short-term stress. Your pancreas. Your pancreas is a confusing little gland at times because not only is it involved in the endocrine system, it's part of the endocrine system, it's also involved in exocrine function, which is your digestive function. So we are just going to talk about the endocrine function of the pancreas within this chapter. And it secretes three hormones that we're going to worry about: glucagon, insulin, and somatostatin. You need to specifically know that glucagon is secreted from the alpha cells of the pancreas, insulin is secreted from the beta cells of the pancreas, and somatostatin is secreted from the delta, that's what that little symbol means, delta cells of the pancreas. Now, glucagon, when it is secreted, it causes an increase in blood glucose levels. So, during what times would glucagon be secreted? Under what stimulus? What's the problem when glucagon would be secreted? It would be secreted when you have low blood sugar. When do you have low blood sugar? When would your blood sugar levels drop? What have you just done? Well, you probably haven't eaten in a while. So it would be maybe when you just wake up, after you've been asleep for 8 hours and your blood glucose levels are low. Those are the times when glucagon would be secreted. It's times of fasting. Okay. Now, insulin, the reverse of that, would be secreted during times of high blood glucose levels, resulting in a decrease in blood glucose. Um, when would you have high blood glucose levels? Well, high blood glucose levels would occur right after you ate. So a lot of times they say glucagon is the fasting hormone, where insulin is the fed, F-E-D, fed hormone, because it's secreted right after you eat. Somatostatin, I'm not going to worry about somatostatin and its purpose. Just know the purpose of glucagon and insulin, when it's secreted, when it's not secreted, and what it causes. Be careful on the test. You have a stimulus, the cause of it being secreted, and then the result of it being secreted. Those are opposites. So take glucagon, for example. If it is secreted when blood glucose levels are low, the result of it being secreted is blood glucose levels will go up. They're opposites. So make sure you read the question and know if it says, what is the cause of this hormone being secreted? Or what effect does it have? So it's a cause and effect kind of thing, and those are opposites. The thyroid gland sits on top of your trachea. The thyroid gland is made up of a right lobe and a left lobe, and you've got the isthmus that connects the two that goes right across the front of the trachea. It secretes three hormones: the thyroxine, which is also known as T4, and triiodothyronine, also known as T3. Both of these are your metabolic hormones. It causes an increase in your metabolism and an increase in body temperature. Why is thyroxine called T4? And why do you have triiodothyronine T3? T4, the 4 means it's got 4 iodine molecules. The T3 means it has 3 iodine molecules. You need to know thyroxine is also T4, triiodothyronine is also T3. Again, those two are your metabolic hormones as a result of TSH coming from the pituitary gland, which is a result of TRH coming from the hypothalamus. Okay, that's your pathway. Now, calcitonin has nothing to do with thyrotropin releasing hormone. Calcitonin has to do with calcium homeostasis. So, the stimulus. When does calcitonin get secreted? Well, calcitonin gets secreted when blood calcium levels are high. Calcitonin will then get secreted, resulting in lowering blood calcium levels. So again, be careful on the wording on that. Parathyroid gland. So what we're looking at here is your thyroid gland. When you flip it over and look at the back of it, you can see there are 4 yellow circles right here. These are representing your parathyroid glands. They're not part of your thyroid gland. They're embedded in the back. They're separate, but that's just where they're housed, kind of like your gallbladder is housed in your liver. It's not part of your liver. It's just housed there. So your parathyroid hormone is secreted by your parathyroid gland, and it is secreted when calcium levels are low, resulting in an increase in blood calcium levels. Your thymus gland, take a look at where your thyroid gland is, okay? Just beneath that sits on top of your heart, covering those blood vessels there. That is your thymus gland. Your thymus gland secretes a hormone called thymosin, and it's going to result in a specific type of white blood cell maturation. So it's going to help mature a certain type of white blood cell called T cells, also known as T lymphocytes. This one is the one that is targeted during the HIV virus. This is what the HIV virus targets, are those specific type of white blood cells, the T cells. Now, the thymus gland, as you get older, actually gets smaller. It undergoes what's called involution, so it actually gets smaller as you age. Ovaries. So this right here is the ovary. You can see it's not actually physically attached to the fallopian tube. Kind of interesting. It secretes secretes several hormones called estrogen and progesterone. These are involved in your female characteristics, female secondary characteristics. That's all I'm going to say right now about the ovary. We'll talk more about that when we get to the reproductive chapter. Testes. Testes are part of the male reproductive system. They lie within the scrotal sac, and they secrete a hormone called testosterone, and they're involved in the male reproductive structures. And that's all we're going to say about this until we get to chapter. Can't remember what number it is, but it's the one involved in reproduction. Now let's talk about the secondary endocrine glands. These are the ones that have other functions besides secreting hormones. The heart being one of them. The heart secretes a hormone called atrial natriuretic peptide, or atrial natriuretic hormone. So let me explain where that name comes from so you can help remember it. The heart has got 4 chambers, 2 upper chambers called the atriums, 2 lower chambers called the ventricles. You've probably heard that before. Well, if you look at the name of this hormone, atrial natriuretic peptide, it means it's secreted from the atrium, specifically the right atrium. So atrial natriuretic. This word right here means sodium. It's the Latin name for sodium. If you look at the symbol on the periodic table, it's Na. Where does Na? Why is the symbol for sodium Na? Because it comes from the Latin name sodium, which is natrium. Okay, so this is going to cause a decrease in blood pressure. I'm not going to get into all of the whys right now. We'll talk more about that in the cardiovascular system, but just know that when atrial natriuretic hormone or atrial natriuretic peptide gets secreted, it will cause a decrease in blood pressure. Now, make a note of all of the hormones we're going to talk about that involve blood pressure. This one's the only one that causes blood pressure to go lower. Every other hormone revolving around blood pressure is going to cause it to go up when it's secreted. This is the only one that's going to cause a decrease in blood pressure. Kidneys secrete 3 hormones. We've got erythropoietin. Erythro means red, poietin means to produce. So this is producing red blood cells. Okay, so erythropoietin is secreted by the kidneys to make more red blood cells. We already know that red blood cells are made by the bones. They're made inside the bone marrow, the stem cells in the bone marrow. But what causes the red bone marrow inside of bones to make red blood cells? Well, when erythropoietin shows up, then the stem cells know, oh, you want me to make red blood cells right now. So that's where that comes from. We talked previously in chapter 5 about vitamin D and how the skin makes vitamin D. And I said, this is just the beginning of the story of vitamin D. This is where it gets made, but it gets activated in the kidneys. So vitamin D goes down to the kidneys, just kind of hangs out there until it's ready to be activated. The active form of vitamin D is calcitrol. This does not increase blood calcium levels, so don't look at that. That is not supposed to be there. I think that is in the wrong place. No, it does not do that. Calcitrol is involved in resorption during digestion. So I guess inadvertently it does, but what it does is it takes calcium. I'm going to go ahead and back that up and say yes, but it's kind of indirect. So it's not like calcitrol. It's not like calcitonin and parathyroid hormone. Okay. Um, this one, calcitrol, remember we said when you take in like substances, food substances that are rich in calcium, they're going to go straight through your digestive system. Well, calcitrol is the little mechanism that allows that calcium to go from the digestive system into the circulatory system. So, in effect, it does raise blood calcium levels, but it doesn't do it the same way that parathyroid hormone and calcitonin do. Okay. And then renin is another one. Now, this is a big one, folks. We're going to talk about renin a lot. Renin, look at what it does. It causes ultimately an increase in blood pressure because it leads to the secretion of aldosterone. We already said aldosterone causes an increase in blood pressure. The stomach, not going to worry too much about all of the bazillion hormones that the stomach secretes at this moment. We're just going to talk about gastrin and just know that it aids in digestion. Adipose tissue. Adipose tissue secretes a lot of stuff. It's fat, okay, but it actually there's a fat metabolism involved within adipose tissue that's pretty involved. So all you need to know is leptin is the hormone secreted from adipose tissue that ultimately increases fat storage. Now, there is on the Moodle page a table of hormones. This is what it looks like. You have it in the packet that you have. This gives you, again, it's just a table. I kind of cut and pasted it so it was easier to see. Here, you've got the name of the endocrine gland. You have the name of the hormone secreted from that gland and its function. Keep in mind this plus sign means it causes something to be secreted, where the minus sign prevents something from being secreted. Okay. I also gave you, again, continued, the endocrine gland, the name of the hormone, and its function. I try to point out the ones that are involved in blood pressure. Keep in mind, antidiuretic hormone, also known as vasopressin. Look at another one here, aldosterone, increases blood pressure. You need to know all of this. I'm just kind of floating through here a little bit here. We already just kind of talked about these. Thyroid gland. So we talked briefly about these two metabolic hormones right here. Yes, it secretes calcitonin, but that's calcium homeostasis. T4, also known as thyroxine, also known as tetraiodothyronine. T3, also known as triiodothyronine. And some key characteristics here is T4 contains 4 iodines, where T3 contains 3 iodines. Parathyroid gland secretes parathyroid hormone. You got your ovary, testes, heart, and looky there, you've got your heart, which reduces blood pressure. And then your kidney, renin right here, raises blood pressure. I did put on here, you have got a video with Armando Hasudigan that he does a fantastic job of going through this. So I suggest, if everything I just said is like a blur, take a look at this. It's about 21 minutes long. There is a note-taking outline that goes along with it. There's also a video created by Khan Academy over these hormones that is a great hormone review. That's another great one to watch. Keep in mind the definition, the understanding of negative feedback and how that works. I used calcium and homeostasis as an example here. So if blood calcium levels rise, that's going to cause the thyroid gland to secrete calcitonin, which is going to cause blood calcium levels to go back down again. So again, you have that negative feedback, right? Positive feedback is one that prevents you from maintaining homeostasis. It tends to be detrimental to the body, with the exception of childbirth and blood clotting. These were the two that we talked about previously in AMP1 that are beneficial examples of positive feedback. Now, some organs which we already kind of briefly talked about. One, I introduced it a little bit. Some organs actually have both endocrine and exocrine functions. Keep in mind, endocrine means it's going to stay inside the body, not secreted through a duct and travel through the bloodstream, where exocrine is going to leave the body through some type of duct. So the pancreas, ovaries and testes, liver, and kidneys can both be endocrine glands and exocrine glands. I shouldn't say glands. I should say they have endocrine and exocrine functions. So the pancreas, the exocrine part of it, it does have exocrine functions, and this is going to be for the digestive system. We'll talk more about that when we get there. The endocrine part of it, you do need to know, is insulin and glucagon, which we've previously mentioned, and this is going to help maintain blood sugar. You need to know that glucagon is secreted by the alpha cells and insulin is secreted by the beta cells. Don't forget that your somatostatin is secreted by the delta cells. Ovaries and testes, exocrine function of the gonads is the production of gametes, sperm and eggs. They will eventually leave the body, right? That's the exocrine function. The endocrine function is they secrete estrogen and progesterone for the female and testosterone for the male. The liver, again, both has exocrine and endocrine functions. The exocrine part is going to be the digestive system component, which is where it secretes bile. You can see it represented in green here in the picture. That's going to secrete bile. It is going to enter into the small intestine, and that's for your digestive system, then into the large intestine, and then out of the body. The endocrine part of the liver is it does secrete substances known as insulin-like growth factors, IGFs, and you can see right here that growth hormone, which we said I'm not really going to ask you about growth hormone, but it does trigger IGF to be secreted from the liver, which then targets all of the structures necessary for growth. Kidneys, exocrine function, absolutely. It secretes urine, which is going to end up exiting the body. But the endocrine function, like we said previously, it secretes erythropoietin, which is going to cause red blood cell production. Calcitrol, which is the active form of vitamin D, will take calcium from the digestive system, put it into the circulatory system. And renin, which is part of a long pathway, ultimately causing an increase in blood pressure. Now, again, I did say a minute ago, you do have links to Armando Hasudigan's video, and there is a note-taking outline there for this specific video. And that outline, like I said, that red arrow is going straight to there. So that way you can download that if you want to and use that as a guide to help you while you're watching the video. And then here's the video. It's in two places in the PowerPoint, but that's okay. It's a good one. And that concludes Objective 9. So if you have any questions, keep in mind we have tutors that are available, and they can even meet with you. If you just send her an email, she can meet with you outside of the normal posted times if you have any questions. And then the next part, we will start the next chapter on the next video.